An auto manufacturer is comparing the gas mileage rating for one of its cars with cars from two other brands in the same class. Is there evidence of a difference in the mean gas mileage rating for at least one of the companies? So notice in our data set, we actually have three companies that we're comparing, since it's one of the companies, I don't know which one it is, and two others. And we are just trying to see, are these things equivalent, or is one of them different? So our first step in performing this is let's set up our hypotheses. So that's step one right here. And we see that, again, the way we can write this is that our means are all the same. That's the assumption, that the first mean of the first company and the mean of the second and the third are all equal. And our alternative is best to write in words. At least one of the mean MPG ratings is different. So if one of them is wrong, then the whole hypothesis for the null is wrong. So step two, the name of this again is either Anova F-test, one-way Anova, anything that has the Anova in it is fine. Our third step, again, what is the condition that we're assuming here is, again, that they are random and independent. But not only that, but these distributions we're hoping are normally distributed for each one of the populations, and they all have the same variance. And we can actually somewhat verify that when we go through the calculations, as you'll see. So let's see how we do this for step 4 to do the Statcrunch process. So here we have everything lined up in 3 different columns. That's one way we could do this, probably one of the easier ways. And we're going to go to Stat, Anova, one way. So again, we can select all those columns here. The other way, if you did have them all in one column and their labels, you could have chose this as well, where we select the column and the column with the labels here. But here, since they're in separate columns, we'll just select all 3 of them. And I will also just create the dot plots just so we can look at this, these graphs and see how these conditions are satisfied. And when we do compute, we get our analysis of variance and our Anova table here. So it has a lot of different things. Again, if you're more interested in the background behind this, that's fine. You can go look and find some more information on that elsewhere. But we're just interested in, can we interpret the results? And again, that would be the F-stat, or the test statistic here, and the p-value. So that's what we're going to report, the 2.707 and our p-value of 0.107. Now, going back to number 3, I did say that we would look at this. I created a dot plot. So one thing we notice here is there doesn't seem to be any skews. It seems mostly the same and evenly spread out. So that's a fair enough evaluation to see if it's going to be symmetric. And the other thing we notice is that the variances, right, how spread out they are, seem to be about the same for each of these. So just the distances between them look to be about the same. So finally, we can evaluate this. We'll obviously use an alpha of 0.05 since it's not given to us. But we can make our final conclusion. So step 5, we see that our p-value is definitely greater than 0.05. So we're going to write, since the p-value is greater than our alpha of 0.05, we fail to reject the null hypothesis. And what does that mean for us? There is insufficient evidence to show that at least one of the mean MPG ratings is different. So these companies are basically, for the most part, equivalent. Now, maybe it's not equivalent, maybe we made an error, and it's just by random chance that we weren't able to have enough evidence, but that's all we can do based off the p-value. Because looking at the graph, it actually looks like one of them might possibly be higher. It just was not high enough to make it significantly higher compared to the other two.